Types of chemical reactions. So we like to categorize chemical reactions because it makes it easier for us to then work out a few things. Firstly, it makes it easier to work out what our products are likely to be when we're writing our chemical equations. Secondly, it makes it easier for us to know what types of bonds are being broken, what types of bonds are being made, which helps us to understand what changes are occurring to the atoms. So, remember, first of all, that a chemical reaction is something in which we have bonds being broken and new different bonds are being made. So we might be breaking covalent bonds or ionic bonds, but the ones that hold the substance together. We make a new chemical substance and it's going to have a different chemical formula. And this is how we distinguish it from a physical change, like a block of ice melting, because that's going to have the same chemical formula at the end, and the same bonds are still within the substance. We can categorise them based on the types of reaction. We can categorise them based on the types of bonds that are broken and made. First one we're going to look at are combustion reactions. Now, for all combustion reactions, oxygen is one of our reactants. So that really helps us to write our equations, because we always know it's something reacting with oxygen. Generally, a lot of energy is given out, such as in a fire. Most commonly, it involves a fuel. Okay, and if we are combusting a fuel, then normally we make carbon dioxide and water. The only difference would be if we burn hydrogen, we just make water. If we burn carbon, we just make carbon dioxide. But all other fuels, we're making the two, carbon dioxide and water. If we burn something different though, like a metal, our product is the metal oxide. If we burn potassium, we get potassium oxide. If we burn magnesium, we get magnesium oxide. Neutralization reactions are when we have an acid that reacts with a base to make something neutral. Okay? They have a general formula, which is our acid plus our base gives us our salt plus water. Now, a salt means an ionic substance. It doesn't necessarily mean that it's sodium chloride, though sometimes it is. If your acid is hydrochloric acid, as we see in the diagram down here, and the base is sodium hydroxide, then your salt would be sodium chloride, but it could be any other ionic substance. And as the diagram up there shows you, we can use an indicator to see when the reaction's taking place. Decomposition reactions. They're ones where we have one substance breaking down to make two or more substance. So you start with something, we'll call it AB, and it breaks down to make two separate things, A and B separately. Okay? So for instance, we can take water, we apply an electric current, and we can separate it out to make oxygen gas and hydrogen gas. Okay? Or we could take a mercury oxide powder and using a bit of fire to start the reaction, we can cause that to break down. Precipitation reactions, that's where we have two solutions, so two things which are in solution, completely dissolved. Generally, you can see through them, okay? They might be coloured, but they will be clear, not opaque. And they will react, and one of the products would be a solid. The solid that we make is called a precipitate. Okay? It precipitates out. Generally, we've got everything that's ionically bonded, and they swap partners. Okay, so we'll call the first one AB, and that in brackets AQ means aqueous. Okay, so our cation is A, our anion is B, and it reacts with CD, cation A, cation C, anion D. When they swap, A will go with D, and B will go with C. And let's say that when A goes with D, it makes our solid. Okay, so we've made an ionic lattice. It's coming out of the solution, and that's when it starts to go opaque.